Okay, let's practice all those different vocabulary words. We're going to start right here. The first thing you're going to want to do is graph this function. Now you can do that on your graphing calculator, but finding all these things like the intercepts and the increasing and the decreasing takes a lot of button key pushing on your graphing calculator. So I have a suggestion. Use Desmos instead. And Desmos does a really cool thing. So we're going to go to Desmos, graphing calculator, type in our equation. So this one is 2x plus 3. And I'll do projector mode so you can see this better. Now you'll notice if I click anywhere on my graph, I have these gray dots come up. And if you click on the gray dots, it shows you what the point is. When you graph it, those gray dots are all the important points you need for this assignment. So we're going to copy this onto our paper and label those 2 points. So we had one at negative 1.5, comma 0, one at 0, comma 3, and then like that. Now, and I want to label them negative 1.5, comma 0, 0, comma 3. Now I have a lot of different things I'm going to write here. So I kind of have a template that you can copy down and then use that. And then we just have to fill it in. So we need X and Y intercepts. We need maximums. We need minimums. We need increasing and decreasing. We have positive and negative. We have end behavior and our 2 types of end behavior. So we have limit as x goes to infinity of f of x and limit as x goes to negative infinity of f of x. And then symmetry. That's everything we want to know. So that's the template you can copy down for 2, for 3, for 4, and for 1 through 4 on your assignment. Those same things. Let's start filling them out. X-intercept is where it touches the x-axis. It is always a coordinate point. So this touches the x-axis at negative 1.5, comma 0. Now, you can have more than one x-intercept or you could have no x-intercepts. It's just whenever it touches the x-axis. Y-intercept is where it touches the y-axis, also a point. Only have one this time. Maximums and minimums. It's where you have a y value that is less than or greater than all the ones around it. Usually, maximums look like a hill and minimums look like a valley. So if we look at this graph, I don't have any max or min. So I'm just going to put none. Increasing and decreasing. This is where you're going to look at your graph and read it like a book. So read the graph from left to right. And if I read it from left to right, I can see that for this graph, oops, that's not what I wanted. This is what I wanted. The entire graph is increasing. From left to right, the whole graph is going up, increasing. So that means my increasing will be from negative infinity to positive infinity, the whole thing. And in this one, I don't have any decreasing. Next, I want to do positives and negatives. So positive is above the x-axis. Negative is below the x-axis. So if I want positive, it looks like it's going to be positive from negative 1.5 all the way to infinity. So from that point 1.5 for the rest of the time. Now, question is parentheses or bracket. Positives and negatives will actually always be parentheses because at this point, negative 1.5, it's 0. 0 is neither positive nor negative. It's neutral. So that's why we want to go up to negative 1.5, but I don't want to include it. For the negative, it would be from negative infinity up to negative 1.5. So make a note, these will always be parentheses. And in fact, increasing and decreasing are the same. So there's those. End behavior is next. So what this end behavior is saying is as x goes to infinity, so that is to the right. So as x moves to the right, what is the graph doing? Is the graph pointing up? Is it pointing sideways? Or is it pointing down? In this one, as the graph goes to the right or to infinity, the graph is pointing up or to positive infinity. Then we also have, as the graph goes to negative infinity to the left, this graph is pointing down, so to negative infinity. That's what those statements mean. As x goes to infinity or the right, where is the graph pointing? Up. As x goes to negative infinity or to the left, where is the graph pointing? Down. Last, symmetry. So check for symmetry. First, does this graph reflect across the y-axis? Nope. Does this graph rotate around the origin? Nope. So symmetry, none. There's that one. In the next one, I'm going to have you graph it on Desmos, copy down all the important points, and then copy our template in, and in the next video, we'll start filling it in.